Hey guys, this video is about simplifying radicals and radical operations. In order to understand how to simplify radicals, we want to first review all of our perfect squares. So that's any number squared to the second power. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and etc. So go ahead and list out as many perfect squares as you can. I'm going to go all the way up to 100. 8 squared is 64, 81, and then 100. Okay? So I would expect that you would know all your perfect squares up to 100. If you ever forget them, you can always calculate them on your calculator or raise any number to the power of 2. Okay? So we're going to start off with a basic example. Simplify the square root of 18. So what that means is we're going to simply look to see if any of these perfect squares are a factor of the number inside of the radical. So I'm going to look across my perfect squares. I notice that, yep, 9 goes into 18 because 9 times 2 is 18. So if this is starting to look like a factor tree, it's a very similar idea, but we're going to break this up into, instead of saying the square root of 18, this is the same as the square root of 9 times the square root of 2. And we're doing this on purpose because we know if we try to take the square root of 9, it will simplify to be a whole number since it is a perfect square. And we know that the square root of 9 is 3. The square root of 2 can't be simplified at all, so we simply leave it, and that's our final answer. Let's try a few more examples together. Example 2 says simplify the square root of 130. So again, you want to think of, out of all these perfect squares, do any of them go into 130, right? Right now I can't think of any numbers off the top of my head without using my calculator, so I can do a factor tree. And I'm going to start splitting this up. 13 times 10 gives me 130. Neither of those are a perfect square. Again, 10 can be split up into 5 times 2. And looking at each of these numbers on our factor tree, none of them are perfect squares. If that happens, that tells you that this radical is already simplified. So you would just write simplified. It's really important that you check and that you finish the factor tree, because sometimes it will appear as though none of the perfect squares go into it, but it might. Okay, let's try this one. 3 times the square root of 50. Notice that the 3 does not have a radical, so we're just going to leave that out in front. That's just a whole number. This just means 3 times the square root of 50. So we're going to try and simplify the square root of 50 just like we simplified the square root of 18. Right away, we probably can recognize that 25 is a factor because 25 times 2. And we know that the square root of 25 is really the same thing as 5. So I'm going to again carry down this 3. The square root of 25 is 5. And times the square root of 2 can't be simplified, which we know already from example 1 because none of those perfect squares, besides 1 never really counts because it's not going to allow you to simplify. And then we can finish this last step. 3 times 5 gives us 15. So the final answer is 15 root 2. You probably noticed that I just multiplied the 3 times 5, but then I didn't multiply it by 2. And the reason that I did that is because you can think of the 3 and the 5 kind of like terms. You might remember that from algebra. Since the 3 and the 5 both do not have a square root on them, it's okay to multiply them. They're just 2 whole numbers. But since the square root of 2 has this symbol, it is not the same value as 2. Okay? So it must stay under the square root. Let's try that same concept on example 4. So notice we've got 2 numbers that don't have a radical and then 2 radicals. So the first thing I'm going to do is rearrange this to put my whole numbers together and then my radicals together. So I can easily simplify 3 times 2 to give me 6. And since both of these values have square roots on them, I can also multiply those together. So that would give me 8 times 5, which is 40. Okay, now this might be a little bit easier for you to simplify because I can look up at my perfect square list and really easily notice 4 goes into 40. So I'm going to carry down my 6, and I'm going to split this radical up into 2 smaller radicals that multiply to get 40. 4 and 10. Carry my 6. The square root of 4 is 2. And remember, if there's nothing in between two numbers, it means they're being multiplied, right? And then the square root of 10. 6 times 2 is 12. Then I want to check, you may not be done, check this list. Do any of those go into 10? No. So I'm done. Alright, our last question for this video is, how do you know if a radical is simplified all the way? And the way we're going to be able to tell if a radical is simplified all the way is once we get down to the point where our radicand, the number underneath the radical, has no perfect square factors. Okay? The examples we've done so far weren't so bad, but if you get into these really large numbers, for example, 2 times the square root of 192, then it might be a little bit more difficult to figure out what perfect squares go into a larger number. So we're going to carry down the 2, and right away I notice the sum of these numbers, 1 plus 9 plus 2, gives me 12, which is a factor of 4. So I'm going to test this to see if 4 goes into this number. So you can use a calculator if you're unsure. So 192 divided by 4, that gives me 48. So I'm going to split this up, 4 and 48. I'm going to still keep simplifying because I know the square root of 4 is 2. I know 2 times 2 is 4. And we're going to stop there. No? I think some people are looking at this and maybe questioning why we can't leave the 48 here. Well, 4 also goes into 48. Square root of 4 is 2. And then we have our square root of 12. So this gives us 8 root 12. But we're still not done because 4 still goes into 12. So this would give me 8 times 2 times the square root of 3, which is 16 root 3. That's a lot of steps, okay? But you don't have to do it in that many steps. You can if you would like. I recommend always looking for the biggest perfect square. So if I were to do this, I would set up my problem, right? And then I would hop on my calculator and test all the perfect squares. So I'd go 192 divided by, we already know 4 works. We already know 4 works again, which means that 16 works, but still we know that 4 is going to go into that 12. So I'm going to try maybe 36, no, maybe 64. So see how testing the biggest square root is going to save you a lot of time in the end. Square root of 64 is 8. 2 times 8 is 16. And we arrive at the same answer that we got before in just 2 steps. I don't care which way you choose to do this, as long as you leave your radicals simplified all the way. For example, if you left this as your answer, you would not receive full credit. If you left this as your answer, you would not receive full credit. So 16 root 3 is the final answer, and that is the only answer that you would receive full credit for on a problem such as this. I hope this helped you guys out. If you need to, you can watch the other videos that are put into this section for simplifying radicals and radical operations.